All right, so in this session, I'm going to share some kind of insights on how to get started with some of the basics of statistics. So we just continue to get closer to some of those theoretical concepts, and I think we are gradually looping out of some of the basic theories before we enter into full-fledged practical. So if you're actually watching this video right now, one of the things I really wanted to understand is that you just need to work on a single data set, okay? Just the topic can definitely be dismembered maybe in the next 30 days of this particular training that is running in different series. So this is something that is definitely going to be very easy to understand. So essentially what we're just doing right now is just to explain some kind of key terminologies and yes, that actually allows it to make a lot more sense. So I'm not really going to waste so much time. This is just some of the basic information you know about statistics. In our previous session, we've looked at some part of data types in machine learning. Then we looked at, before that, we understood features and rules. And in our first day, we looked at some of the orientation to machine learning. Now, there's actually a purpose why we are following this in series. And today we're going to be talking about statistics in machine learning. And this is just some theoretical concepts that you might already be familiar with. And I'm not really going to say much about the text. I'm just going to explain some of the key concepts and some of the things you need to know. So basically, what statistics is just like those, it gives us the tools to understand our data before we feed it into the algorithm. Okay. So everything statistics now is what do we want to feed into our data algorithm? Do we want to put our mean? Do we want to put our mode? Do we want to measure central tendency? Essentially, this is just like kind of a scratch of the surface of what you need to know because uh, everything we're talking about statistics in this particular session is exactly what you're going to meet in your project, in the research or kind of tabular comparison that you want to run. So this is just more like a kind of tailored teaching that is narrowed down to your ability to execute that project. So machine learning models are more like pattern detectors, right? That's what we agreed in our first session. If you've not watched that, you can actually take swipe back to our previous videos. And it's just like trying to learn the kind of relationship in data to have the capacity to make predictions, okay? So it's just garbage in, garbage out. So this is just a very simple insight that we need to understand. Now, what statistic really is now, I'm not really just going to say much, okay, because basically what we saw from our previous session, uh, essentially it highlights a very key insight of what statistics means because when we were talking about data types, we talked about numerical, we talked about categorical, we also talked about some kind of continuous, scale, and we looked at count. uh, these are actually parameters that we try to understand from our data, okay? And the implication of that is that in statistics, what does it really mean, okay? So we just want to, whenever we're talking about statistics, we're just trying to summarize large amounts of data, okay? So we can understand them and all of that. So just imagine you're trying to describe 10,000 patients' records to a colleague, okay? You can't read them all out. Instead, you will say something like most patients were around 45 years old and all of that. So think about statistics as if we have a given data set, how are we going to present it to people? Let's say, for example, now we have a lot of people here now. There's an outbreak of tuberculosis or HIV and AIDS. How are we going to relate that data to people? We will use terminologies like, oh, the mean, or we might say that the frequency of, or the count, or you can say use terms like probably the percentage of HIV infected patients in this outbreak is so so and so. Okay? So we can have something like kind of a distributed, mean of some kind of maybe cryptocurrency uh, prices. Now, what are we going to look at when we are looking at it? If we want to summarize that, we can see something like what is the mean cryptocurrency price as of the last 7 days. So that word mean is a statistical term that we use in summarizing data. So this is just very, 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 very simple. I feel like even somebody in basic one or JSS one is definitely going to cope with this session because this is just like trying to summarize numbers, data. How do we summarize it, particularly in machine learning? Okay, all right. So I'm just definitely going to leave this slide on my repository. So if you want it, of course, you can always get it from my repository. Now, another key thing we'll look at on our core is population versus sample. So whenever we talk about populations, we're talking about the entire what group. And for sample, we're talking about a subset that is being represented from that what particular what population. So this is something that you're going to be familiar with in data set. So if you're in your methods or you're saying, okay, that you're going to work with 300 people. That's the data set you got. That doesn't mean that that's the total population, right? So that's just like kind of a representative of the data set. So you'll be having something like your sample size, and n is equals to 5,000, 500, 200, to train your tables, your features and rows. I hope you still remember that features and targets. So those data, those information there is what we call what our sample. So this is something I'm sure we are familiar with because when you're giving out, issuing out questionnaires, or you're giving out, collecting survey, or any form of, insight you're trying to gather from the population group, right? Uh, Basically, you're doing what? You're collecting what? Population what? You're collecting sample data from a given what? Population. So that is just what it means. Now, I think I'm actually going to do something slightly engaging. And I'm just going to show you what this means, right? Measurement of central tendency. You don't really need to stress yourself with some of this text. So I'm just going to show you something right away. So I'm just going to come here. I'm going to click new. I'm just trying to click that. I don't know. So I'm just going to create a random blank document. I'm going to title this machine learning short illustration. Okay. I don't mind me. I pay so much attention to details. So I'm just gonna close that. Now I'm going to be using this. Oh, what's this? Sorry. Okay, I just want to show. Okay, yeah, I think I can. Okay, I can just leave that there. Now, let's look at this kind of data now. Like, we remember, whenever we are doing machine learning, right, we said we have what we call what? Rules and what? I'm just going to highlight that. Maybe this could be age, this could be sex, this could be mean blood pressure, okay? And this could be presence, want to predict presence of hypertension, okay? So here could be 0, 1, 1, 0, okay? So what is 0, okay? So this can also mean no, yes, one will be doing what we call label encoding and no, okay? So this could be present, absent, or whatever, okay? So I will explain that. So here, it could be 22.4. It could, what's usually blood pressure? Someone tell me what's the range for blood pressure? What's the range for a blood pressure? Okay, I'm just going to go ahead. Okay, so Here could be 43.2, it could be 32.1, it could be maybe 87.3, okay? Now here could be male, female, 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 okay? And then here could be stuffs like, okay, 19, 43, that's 22, 20, 34. Now, basically, what we are trying to say is that, so what it means that we have something like age is equal to maybe 19, then we have 43, 22, and 30, 34. Okay, I'm just going to increase this. Okay, so that we can be able to see my screen. And maybe we can have 70. Now, these are what? These are values, right? These are actually what? Values. Now, the question now is, what are we now talking about here when we mention central tendency? Okay. So just imagine you're trying to describe the age of patients and all of that. We just want to see what's the central value and all of that. Now, what we're going to talk about now is that there are three main ways we can actually answer this question on our data. And this is something I'm sure we're already familiar with. And in statistics, there is what we call what? Central tendency and what? Measurement of central tendency and what? Sorry, I'm just going to copy this. There's a reason for that. Measure, and we have what? Measurement of dispersion, okay? Where we're trying to understand the spread. Now, this is simple. What are the parameters when you're measuring for central tendency? Mean, mode, median, right? What are the parameters whenever you want to measure for dispersion? You look at range, you look at maybe you can look at after range, you can look at degree of freedom, okay? Then you can look at standard deviation, which I'm sure we are all familiar with in biostatistics, and we have variance, all right? And I think that's enough for now. These are actually enough for now. I'm just going to knock out this so that we look at some of the ones that are quite familiar with us. So what do we mean by a mean? So in statistics, whenever we talk about the mean, we're talking about what? The summation of all these parameters divided by what? The number of, that's the number of existence, 1, 2, 3, 4, 5. So basically what I'm trying to illustrate here is that when we are trying to measure the central tendency of any given distribution, normal distribution of numbers, or whatever, because these are some of the things you have in your data set. And the reason why I pasted this here is that so that you can actually have a picture, a clear picture of what your data set is all about. Do you understand? Because the reason once you're looking at this now, this is what your data set will look at. So if I'm talking about mean, median, mode, you're not thinking it's something different. This is just in your data set now. Here can be something like gene count. It can be something like maybe you can have something like a bacteria strain score. Maybe you have 1.0. I think I can actually just 1.0, 1.8, maybe 22.4. It can be anything. It's 1.8. It could be any 9.0 minus anything, right? So we can also have negative numbers as well. I hope we're aware of that. So the point I'm trying to make here now is that this is like the foundation of what statistics is all about. We are trying to understand the measures that we've taken. So this is just like the baby step. We're taking the baby step in understanding what this. So even if you've not done statistics before, all you need to know is that after yesterday, where we've discussed the types of data types, you have now come into the stage now to now know that, okay, there are actually some distribution how we can summarize numbers. Because if you're asked to report the age, I'm just going to delete this, sorry, excuse me, I'm just going to delete that. So if you're asked to report the age of people in your class, what will you likely say as definition of statistics? You say, oh, the mean age of our class is 21 points. So that's like the average age of everybody in our class. Okay. Okay, the total age, I can say that the median is what? 17.2. Okay, so all these things are actually very important. These things are not here for fancy. Oh. They are very, 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 very important for you to know in machine learning because you need to understand how to do what? Summarize what? Data. And that is why one of the reasons why I gave this example. I could literally have just explained age and this, but the reason why I painted this picture is so that you just have an idea of what you are going to be doing. And basically, when we talk about mode, what is mode? We usually say mode is the what? Highest occurring number. Okay? And then we talk about median, talk about more like the center what value. So all these things are what? Parameters for your what? Measurement of what? Central tendency. Now, how about when we look at, when we want to now measure the spread, not no longer the central tendency now, because this is more like a central tendency, right? We want to measure the spread, dispersion, okay? You can actually call this spread, okay? What is range? Range is what? The distance between highest minus what? The lowest. So if you want to talk about the range now from your age in your machine learning data set now, 19 minus what? 43. That is the what? The range. That's the spread. So this is just one parameter though. We'll have more to look at. Then what standard deviation? Standard deviating. Your boyfriend is deviating from the point. He's deviating from the main point. The mean point. So standard deviation is like the distance between what? The mean from the what? I'm going to explain that. Sure, let's get into the slides so that we will actually see all of that because I might end up explaining all the slides even before I open the next slides. So the mean explained already, I talked about it as the word average. Everybody here knows how to calculate the mean, right? Nobody will say they don't know how to calculate the mean in a given in a given distribution of any kind of data set. You basically know how to do what? Compute the mean. Now, what about the median? Now, when we talk about the median, we are talking about the what? In the median, we are talking about how numbers can be whenever in machine learning, whenever we are trying to explain the median, we are basically talking about the middle number, right? Okay, the median, everybody here knows how to do it. So look at this fine chick. So she's standing at the what? At the middle. So that's more like the middle number, okay? That middle parameter inside of that data set. So they will definitely show there are already established statistical approaches to calculate that. Okay. Yeah, if you're using NumPy in Python or you're using any kind of package, it's just dot mean, dot median, and all of the dot standard deviation, dot this and all of that. So, but it's just normally important for us to get that. And most times, one of the things I need to let you know is that sometimes health data can be skewed, right? So what's skewed? Skewed now, just look at it like kind of not like say some kind of we might say a kind of like we won't really say differences, but we'll definitely show some kind of examples of skewed data sets. Okay, that's why most times we perform stuff like pipeline scaling and all of that in machine learning because it's very, very important for us to have a clear, data cleanup. You understand? And also using appropriate techniques to make sure that what we have our data in line. So mode, as usual, is the highest occurring value. So when are the times we usually use mode? Most times when we use our mode is whenever we have continuous what we have some kind of inconsistency is in our data set, particularly for categorical. So if we now want to clean up that data set, so think about it like maybe we have somebody fill the data a questionnaire and some places they did not fill it, so they are incomplete. How are we going to clean those places up? We might use the highest occurring maybe variable. Maybe it could be that the highest occurring variable was good, which is a categorical variable, then we will use it as our mode to fill it. But don't worry, all these things are going to be explained because already you know that mode is highest occurring value. You know that already way more than me, right? Okay. So the mean, median, and here, so here we draw some kind of comparison. So symmetric data is when the data is evenly distributed, right? We're definitely going to show that as well. And it's nothing to worry. Trust me, nothing to worry. Practicals is going to cement that. We're just making sure we hold our foundations very right. And it's just more bell shape. I'm going to show you some kind of illustrations. So they all point to the same center, right? Okay. Yeah, somebody can just type symmetric data. Okay, even if I didn't spell that correctly, and so you look at it. Okay, this is just what it is. So you look at how the data set is being distributed. Okay, so across all of these individual samples, you see that there's even distribution in the right and the left. So that's just what it is. Oh, I don't know what's that. Okay, all right. So right skew data here is when you have a long tail high values, like maybe a hospital cost or kind of disease duration. The mean gets put to right. Median mode is less than the median, which is less than the mean. So the median gives you a type of beta. We'll explain all of this in practicals. That's one of the things that makes it very simple. But one of the things you need to actually understand is the metrics that is there, which is for your mean, median, and mode. So what are less common? So left skewed data is more like kind of less common, in any kind of data set because you just have one tail, long valleys, that the mean gets pulled towards the lower outliers. So some of outliers, some of the things I'm definitely going to explain what are outliers. And when we say she's an outlier, more like in a data set, we ask people to report how many times do you read in a day. At least we expect people to say 8 hours. Then somebody is saying 23 hours. That's an outlier because it's above the expected range. Do you understand? So that in that scenario, now it's an outlier because outliers are more like kind of they're actually values that are deviating from what is expected from expected values. So those are actually what outliers. So understanding spread, y average is not enough. So if we are now using just mean median mode, right, then it means that there are still some kind of statistical parameters that we are overlooking. That is just what this slide is talking about. Do you understand? Because we have data set, and in that data set, we do only mean median mode. Then it means that we don't still have a kind of there could be some kind of discrepancy. So imagine two hospitals both reporting an average patient age of 50. Sounds the same. Okay, so but hospital A treats patients age 48 to 52, while B sees patients from 5 to 95. Okay, so you see that there are differences now. Both of them have an average of 50. So look at this 48 to this is from 5 to 95. Yet they represent totally different population with different needs. So what this means is that I just want you to be a bit technical now in understanding what I want to say now is that if only how we are looking at a data set is that we are looking at it from the point of let's say age, this, that, and that. Then we look at another age in another data set. It's true. We use that same judgment. Then it means that there are tendencies that we will not capture some kind of uniqueness in the data. That's why with mathematicians, people that got all these statistical terms now said, okay, oh, instead of us to stop at doing only mean median mode, because when you calculate the mean of people that are between age 5 to 95, right, in a given data set, and people that are clustered around 45, 46, 41, 47, 48, 7 again, 42, 3, 45, maybe you might get a mean of 50. But then that means here we have people that are 5, infants. We have people that are very old, 95. So it means that the kind of conclusions that we'll be making with this and this it's not going to be the same. Unlike that, the mean has given us almost the same range, or when we did median, almost at the same range, or when we did the mode, probably, if at all that is even making any sense. But that's why they now say, okay, no, let us measure dispersion. It's important for us to also understand all these things in a data set. Okay, let us know the range between the highest and the lowest. Let us understand the how much this the highest varies from the center. Or let us understand how these data varies in between them. So that's why this dispersion came about. Do you understand? So that way now, we're not just measuring only central tendency, which even a primary nursery student knows, but now we're now measuring what? Spread, how these numbers spread. So from time to time, you'll be getting several data sets. So it's important for you to now do what? Understand some of these words. Terminology. So let's just continue with the slide. Examples will feed us so well. So range, like I said, is the simplest measure. It's just like the highest, minus the what? Minus the lowest. Okay. So range is the distance between your minimum and your maximum values. If your youngest patient is 18 and the oldest is this, then the range is 64. Okay. So yeah, it gives you an instant sense of the data boundaries. Okay. Tells you where the beginning is and where the ending is. But this is something central tendency will not give you. Okay. Because it's just calculating the mean median mode. So the range uses only two numbers, okay, ignoring every other thing. So just the highest and the lowest. So if there is an outlier, let's say a number that is lying so much above, it will make the range very, very enormous. And even 99% of your data is tightly clustered, okay? It tells you the outer limits, but nothing about the distribution inside those limits. So that's where we'll now go to standard deviation to understand what it means. So what this thing is trying to say that as much as we are measuring dispersion, right? Most times when you're measuring the age of people in a class, there's a particular range that they will cluster around. They will be 21, 22, 24, 29, 26. Even if one person is too old in the class, that is 41, and then somebody is 18 or 17. As much as if there is an outlier, someone that is 90 years old looking for a degree in your class, it still means that using only the range will still not be enough because of what? It can create some kind of what? Uh, it can even, because of that tight clusters that are at the center, then we might not be able to have a complete view. And that is where variance now comes in. So where we now understand how our what, how spread out our values is. So you know the calculation. We'll definitely do that in our in our calculation class. And what do we do for variance? We just measure how far each of the data points is from the mean, okay? On average. So think of it as the average distance from your mean. That is just what it is, right? So this is a statistical term that is definitely going to be calculated along the line in your what? In your machine learning data set. So standard deviation too, is just the square root of the variance. So it's just like it tells you kind of typical distance, a point sits from the mean, okay, in the original units of your data set. So let's take a look at this now. Let's assume that we're looking at this data set now here now. We're looking at this as our what? Maybe let me call this corpus age. Now, what's the variance now? Which is usually S squared, right? If I'm correct. Now, so what the variance is now, is that we're just trying to understand how these values vary from the mean. So the mean of here now could be usually, you can say the mean here now could be X bar, right? I see X
Have
bar.
you tried asking or see more if she tried talking to her? She don't.
Okay, so the mean could be what? X bar over what? Over
Then
maybe.
she tried to talk to her. She doesn't used to respond. That kind. No, the mother that
So the mean could be what? X bar over what? Over n, right? And essentially, that is where we get our, that's where we get our what? Like we want to get the variance. So when you now get that mean, you now, you want to understand from, let me go back there. I'm going to go back there now. So when you get your mean, okay, we're trying to understand how. So let's say the mean here now is 42.1, right? 43.2 or whatever. So we want to understand what's the distance of this from this. How does it vary from the mean? Where does this vary from this? And what does this vary from this? And what does this vary from this? That is what we call our variance. So when we talk about variance, most people will just look at it as big, big English, but they don't even understand, what essentially it's talking about. So set something for our standard deviation is also something that we will need to calculate and estimate because we just want to know like kind of the square root of the variance. So it tells us, it just tells you the typical distance a data point sits from the mean in the original units of your data. That's what the standard deviation does. Now, I'm just going to say something about distribution. So this is very, very, very simple. So a distribution will just show you how values appear in your data set, okay? So you plot all your values on a graph and you see a shape that emerge in the shape of a distribution. So the take of it as something that is kind of a data portrait, okay? Where most values are clustered within the middle with a few strugglers. So I'm not really going to say so much here because all of these things, what matters is the practical, okay? You're already 1 foot into the project, which means you need your data set. Once you've gotten your data set, you can now start performing the permutations, doing data visualization, understanding the distributions, getting some kind of clearer insights and all of that, okay? So this is what we call the normal distribution, skewed, left skewed. Okay, so all of these, don't worry, don't worry, don't worry. What you just need to understand here now is, okay, what is my mean? What's my median? What's my mode? What does it mean? What's the measurement of central tendency? How do I calculate my standard deviation, variance, and my range? Okay, so all of this now here now, what they just basically explain now is just some kind of distribution of your data. Okay, so let's assume that this is age now and they want to now understand how it's distributed on a kind of graph, right? So this is more like what? Symmetrical. So it means that it's balanced. This is asymmetrical. It's unbalanced because it's on one side. So it is even a left skewed, okay? But this is right skewed. So all these things are, some of the basic nitty-gritties of what statistics that you need to have in mind. So skewness is something that is very paramount in health and in our data. I'm also going to make another video much more on this, particularly on skewness. But somebody might be asking, oh, how does this thing now concern my project or my research? Maybe it does because you just need to get that some of those data sets you find in your columns, some of them might be skewed. Okay, so while lab values and counts are skewed, you can't leave negative bacterial counts, okay? Or maybe you see negative numbers, or maybe probably you're supposed to have positive numbers, there are negative numbers, or probably there are some kind of discrepancies in it. So anytime your data is skewed, just the mean doesn't really represent it typically, okay? And that's where most times we now find out that our median becomes what? Informative. So don't worry, it's just the practicals, we make everything what? Sync and get in. So look, let's like I explained about outliers, there are values that lie far away from the range, there are extreme cases, the patient who stayed 90 days when most say 3 to 5 days. So just think about an outlier here. I'm just going to come here. Let's say I'll now come here and have something like 900. Ladies and gentlemen, this is an outlier because there is actually a range where all these values are lying. And we're now having something that's at 900. So this is what? An outlier. So probably that was mistake. The person was going to fill 90 and he filled 900 and all of that. That's why when we perform cleaning, data cleaning, we perform what we call column transformation. We handle outliers. We use what we call box plot in matplotlib to visualize presence of outliers, and then we properly do what? Set them in our data set. So that's just basically what outliers entails, and it's not really something difficult to understand. So outliers really matter because they play a very key role in our machine learning model, okay? They can have an effect on the average. You know that already. Now, when you now have that 42 plus, maybe let's say what's the average here is mean. Look at what this statement means. Now, let's just come here. Let's assume I want to now sum up all these numbers and I want to add this outlier. You see that this 900 here now will make the mean now might be around 92, 91.2 or something because of what the impact this number is having here. So that's why it's important for us to clean our data properly, manage outliers, and then, yeah, get some of the basics, essentials that we need. So it can have a significant effect on the model. Remember, with all this data thing we are talking about, you just to use it to train a model. So in that case, that you can feed in your model a boy that is 19 years, he'll start misbehaving, predicting another thing because of what? Outliers. So we'll definitely show you in practicals all of this. Trust me, it's very simple and easy. Okay, you will always be happy you choose a machine learning path, for your research. So detection and handling, statistics help you spot outliers and all of that, blah, blah, blah. That's just what we talked about. And visualization, okay? Uh, this part now is for you to be able to even spot all of this. We'll talk about visualization more in depth. Box plots, remember I talked about why we use it for outliers, some kind of, quartile, percentile, and essentially histograms, bar charts, and all of that. We'll explain all of this, in our detailed what video. So statistics is really very important in machine learning. I already said that, you know, machine learning algorithms require features, and all of that. Model assumptions, many algorithms, assume certain data properties, all of this basically, we will, look at them in depth and, yeah, in our what? Calculations. And I think actually this is it for this particular session. And I think over the course of, 1 hour or thereabout, I've been able to run you through some model, some parameters for measuring central tendencies and getting started, understanding your mean, median, mode, what outliers are in your data set, and data types, which we explained yesterday, and how your data can be distributed, measured for dispersion, and measured for central tendency, okay? Which I explained that is very, very important for us to really have a very clear glimpse of how to, manage your data. We also talked about population mean, sample, and basically all the, required parameters that one needs to use in getting started with, machine learning as the basics. So I just want to actually, say a very big thank you to you. And trust me, all of these are quite very simple, and we're definitely going to do so loads of practicals. And yeah, I think this is a very great aspect to getting started with machine learning. And of course, I'll see you in the next one. And yeah, thank you.
Thank you, sir.